Hello, everyone. Welcome to Aptera Owners Club. I just went down a big rabbit hole looking at Kevlar and sandwich core composites because I remembered this post from Aptera Motors back in August of 2020 where they talked about Apteras being made with sandwich core composites consisting of carbon, Kevlar, and hemp. And I remember that there were a couple of articles about Aptera using hemp. And we all know that hemp is a very common fiber that's popular right now as a sustainable natural fiber. It has a lot of advantages. And so then I checked back to their FAQ, and this is Aptera's FAQ now. And now they say we are using carbon, glass, and Kevlar fibers in our structural body parts, and we're looking towards more organic fibers like bamboo and hemp for our non-structural parts, and also investigating bioresins, which degrade more easily once recycled, which I'm thinking they're talking about PLA at this point. And so I don't know which one is the more up to date. Is it this Facebook post, which makes it sound like they are using hemp, or this FAQ that's currently on their website, which makes it sound like they're gonna maybe use hemp or bamboo for their non-structural parts, but their structural parts are going to be traditional, probably carbon fiber, glass, and Kevlar. So if I went back and found this article from Hemp Industry Daily where they were talking to Nathan Armstrong, and he talks about how they're using hemp. And for him, Nathan is Canadian, and so Canada is a major producer of hemp fiber. So he was kind of going at that angle, and he made this car called the Kestrel, which was a hemp fiber car back in the day. That one never made it off the ground, but it was an interesting small hatchback. He says that the problem with hemp was that it took up a lot of resin, and resin is the most expensive part of the composite. And how they got around it is they found out that if you use woven hemp, it works out a lot better. So they are planning to use woven hemp from a company in Europe, and he does not list the company. I looked for a company in Europe making woven hemp, and I could not find one. But that's what they were doing. Right now, they were going to ship the fiber from Canada to Europe to get it woven and send it back. And then eventually, they are hoping that they were going to make the powered weaving loom and bring it to North America. And then you could have the raw material and make the natural fiber woven cloth that you're going to infuse it into the composite, all in North America, to avoid the shipping back and forth. And so what are the problems? Oh, yeah, the other interesting thing I wanted to know was, has anyone ever used hemp in cars before? And evidently, two cars have used hemp before. BMW's i3 used hemp in their car, as well as the Porsche Cayman GT4, and they used a hemp composite manufactured by Hemp Flax out of Netherlands. So I went to this Hemp Flax website thinking that maybe they were the company that was doing the woven hemp, but they are not. They do non-woven hemp, so they don't do woven hemp. So these are the problems with hemp, or the advantages or the problems. The advantages are that yes, they they're biodegradable and they're renewable and they have a lower carbon footprint. That's good. The major problem here was that it's not, the hemp fiber is hydrophilic, and because it's natural fiber, it's carbohydrate based and cellulose based, and those are hydrophilic, and most of the resins are petroleum based, and so they are hydrophobic, so they don't bond very well together, and so they don't have a very good bond, and you can't transfer the mechanical load into the fibers, because the way fiber reinforced composites work is that most of the load is being taken up by the fiber, and the resin basically holds the fiber together and helps it transfer the loads between the fibers, but the resin doesn't do much of the load handling. So if the fibers and the resin don't bond very well, then you can't have very good load transfer. So it doesn't work that well. And then it's complex to do. Especially with the weaving fiber, that takes a loom and all this stuff, and so that's hard to do. And then it's harder to trial these things because the fiber is often produced in other countries. Now, this is not a big a problem for hemp because the hemp is made in North America, so that would be pretty easy. So then I found this paper, which I thought was kind of the most interesting. This was the most interesting thing. This happens to be like a senior project by some guy named Brian Rogers at Cal Poly San Luis Obispo. And this was during the original Aptera. And I will link this in the description because it's pretty interesting. This paper goes pretty deep into the sandwich core composite. And this is still the technology that Aptera is using. They're still using the sandwich core composite. And this one is using, so the sandwich core composite, and I will show you a picture of it in here. We'll scroll down. It's a pretty long and involved paper, and I read through it all. I didn't understand all of it because I don't have really the engineering background to understand it completely, but basically this is what a sandwich core composite is. There are two face sheets and then a honeycomb core. This gives extra rigidity, and the sandwich core construction is used a lot in aerospace applications because it's very high strength to weight ratio, and that's really important in aerospace applications. At that time, they were using a e-glass, or it's a type of very refined fiberglass. And if any of you guys are composite engineers, please comment below and educate me and the rest of us, because I may be misunderstanding a lot of what I'm reading because I just don't have the engineering background. So basically, it's a sandwich core, and you can look back at this video from Kirsten Dirksen, and everyone knows about this video. But this is Chris Anthony showing a sample, and here you can see the honeycomb hexagonal core, and it's got a face sheet on this side and a face sheet on the bottom. And you see that these hexagonal cores are probably about 10 millimeters, probably a little bit less than a centimeter in size. And so if you go through here, he goes through the various things. So back then they were looking at face sheets made by Vector Ply, and I found out Vector Ply is still in business. And Vector Ply basically uses fiberglass sheets. So I'm thinking that they may be using a hemp-based face sheet, or maybe they're using a hemp-based core. I'm not sure. The honeycomb core comes from a company called Lanter. Back then, it was called the XF6 Soric core, and you see right here, this is their core, and you see this hexagonal structure. And if you look at the size, I'd say that's about 20 millimeters, which would match up pretty well with this. This looks like it's about the same size as that core. So I don't know if they're still using Lantor's SF6 core or something similar to that. This is what they're using. They're going to use vacuum infusion. So we know that's the case because we've heard Chris Anthony and CM Fambro talk about that. They're going to use this vacuum infused composite structure. This has a couple advantages. It doesn't release the volatile organics into the atmosphere, so it's a little safer for everyone working on it. So this is the way they're going to do it. You put a face sheet, you put the core in, then you put a back sheet on here. And I don't know what their current construction is. Is this carbon fiber? Is this hemp? Is this Kevlar? Is this hemp? I don't know. Back then, this was all fiber, glass fiber, essentially. And so then he was looking, basically, this was a validation experiment where he was looking for, at this other company called Ceretex, and they found out they're still in business, and he was seeing if their product was just as good as Vectorply, so they would have redundant supply chain things. And I'm sure this is the kind of work that the engineers at Aptera are doing now. They're trying to test several different suppliers and make sure that once they make the composites or other parts of the car, that it meets their specifications. And then there's several papers about this sandwich core, sandwich core construction. And you can see, interestingly, this is also by Cal Poly University. So it looks like they have a lot of expertise in that area. And it looks, they're doing a lot of sandwich core. You can see how they made it here. Here's the core and the two face sheets, and they're testing them. And they found out that in these papers that the honeycomb structure based on hemp or the face sheets based on hemp performed very well. So I'm very interested to find out if when I go down there, I'll be able to get any information on the actual composite. Have they nailed it down yet? Or are they still looking? Are they going to use bamboo and hemp? Are they not? Who's their suppliers? There's probably information that they're not really going to want to tell us right now until they lock down their supply chain. Or maybe it's just trade secrets and they're never going to exactly tell people. But it's a very interesting construction method. I never knew anything about the sandwich core construction until I kind of started going down the internet rabbit hole looking at this thing. But yeah, I just thought that this paper was very interesting. And it talks about all the different things that they were looking at and who their suppliers were. And exactly what product they were using when they were investigating the first iteration of Aptera back in 2010. And I think that the basic technology that they're planning on using is the same, the sandwich core construction with the hexagonal structure, which you see here and which they mentioned in this paper. And I wish that we could find more information just because it would be interesting from an intellectual standpoint about who their supplier and what the materials are in the face sheets and the hexagonal core. All right. Well, I don't know how interesting of a video this was, but I just spent like 40 minutes reading into this, and I thought that I'd make a video and tell you guys what I found out. Again, I thought that this paper was really interesting, so I will link this paper, which gives lots of good information about the first Aptera, which I think is applicable to the current Aptera, mainly in terms of the sandwich core construction. I think probably the materials and the suppliers are going to be different, but who knows, maybe they're the same because these companies are still in business. Okay, well, if you've gotten to the end of this video, you're probably very invested in our channel. So we have a Discord channel, which is linked in the description below. And also, one of our viewers happens to be a graphic designer and is helping make us a new logo, which I've seen some samples, early samples of it, and I think it's going to look awesome. And hopefully we will incorporate that into the intro video pretty soon. And maybe we'll start making some t-shirts and hats. If you guys are interested, let me know. We can definitely set that up. Those things are pretty easy to set up. And so if you guys want that kind of stuff, I can definitely do it. Okay, well, thanks for watching, guys, and have a good day.